Hey folks, Josh Klahr here. I work at Snowflake as a product manager. I've worked here for a bunch of years on all things related to our core database engine. And today we're going to be talking about one of my favorite features, which is Snowflake Semantic Views. I thought I'd kick things off just to set the stage about what a semantic view is. And then we are going to get a live demo from Chris Marland, who's going to show you some pretty cool stuff about semantic views, but also how Cortex AI helps in the creation of those semantic views. So let's get started. What is a semantic view in Snowflake? We launched semantic views earlier this year in June uh, as a native schema object. So just the way you think about a table or a view, we now have a new object in Snowflake called a semantic view. And a semantic view serves two main purposes. The first is it provides really rich metadata to our AI products like Cortex Analyst and Snowflake Intelligence so that an LLM knows how to answer an end user conversational analytic query. It describes base tables, it provides custom instruction sets, it provides relationships between those tables. It even projects things like calculated metrics and columns so that you can really reduce hallucinations when you're talking to your data. Um, but because semantic views are a native database object, this also means you can write a declarative SQL query against them. So if you're building an internal Streamlit app or you're using a business intelligence tool and you want to make sure that your CEO, when he or she is talking to the data, is getting the exact same answer as your internal applications and dashboards, semantic views unlock that capability. So you're getting the same answer regardless of the surface. Um, Snowflake semantic views, because they're native objects, they benefit from all of the built-in security and governance and reliability that comes with Snowflake. So semantic views can be securable with role-based access. We will respect things like masking policies. Semantic views support things like replication. So all of the nice things you've come to expect from Snowflake tables and views, you get with semantic views. What is a semantic view? Well, and you're going to see this in the demo. You start with identifying the base tables you want to build your semantic model on top of. And you define the relationships between those tables. So imagine you've got a transaction table and you've got a date dimension and you have a lookup for product category. You define those relationships. And then on top of that, you project LLM and human queryable elements like metrics, count of customers, count of orders, or key dimensions like date and product. And that's what we expose to query interfaces. Again, you can write a declarative SQL query. You can do a metadata call that describes what's in that semantic view. And ultimately, this puts customers in a position where whether they're talking to their data or they're writing that declarative SQL query language, they're getting the exact same answer. And this is one of the things we hear from a lot of customers is I've built these internal data products today, dashboards, reports, business intelligence. I'm unlocking conversational analytics, and I want to make sure I'm getting the same answers. And so semantic views really are trying to solve that problem. Now, the thing that a lot of our customers are trying to figure out is how do I build and maintain and keep my semantic models and semantic views in Snowflake up to date? In hearing what Chris has been up to, I was really excited to hear about his approach to doing this. Again, he's also going to demonstrate some other cool Snowflake capabilities. So I'm going to hand it off now to Chris, and he is going to walk us through the creation of an actual semantic view in Snowflake.
Thank you very much. And all I can say is, I am somewhat of a lazy person sometimes. I think it's very often difficult to type out all the thoughts going on in any person's head. And so I actually think might be quite nice is when developing a semantic view, what if instead of having to write down and articulate in text all of these thoughts, how about we do some voice to SQL? And we can do that because not only do we have all the AI functions have been out for a while, we have a brand spanking new one released only a couple of months ago, AITRANSCRIBE. So actually, I can feed audio files to Snowflake, and it will use its magic. Not magic, it will use advanced technology, but it feels like magic. It will use its magic to produce a transcript. I can then feed that transcript into a prompt, and in doing so, I can then get it and train it and convince it to produce a semantic view based on my data, which I think is quite exciting. So to put this into reality, what I've done is developed a Streamlit app that will do this. So let us begin. So just to start off with, I have my imports. I'm bringing in some libraries that are quite useful. And then I have some constants, my session, the stage name, the docs of it. I'll be clearer in a little while. Query sample size, again, in a little while, you'll see what I'm doing there. And then the actual model that I'm using to produce the SQL, okay? So first off, we need to import the audio. So my first function is going to be record audio. And just what I'm doing here is st.audio input. I'm allowing the user to click record and produce something. So what I'll do is I'll just go down here, maybe call this section orchestration. And let's run that just so you see what's going on here. So there we go. There is my audio input. I can click this and describe the data that I'm going to be using. So what I'll do is I'll flick over here and I'll just do show tables in schema. What I'm going to do is I'm going to use our March 25 case study. So this is a bit of a training data set we use in my company before we send consultants out into the real world. We've got some tables here, full sales in this test array. We'll ignore them for the purpose of this. We've got an invoice, a store, a vendor, a country, and category. So as you can imagine, what we're talking about here is really our accounts payable and some information that we have on that accounts payable. So that's some nice info that I can feed into this this prompt. Okay, so what I'll do is I'll click record. I want to produce a semantic view that is going to describe some of my accounts payable data. With that, I've got invoices as my fact, and then various different dimension tables that join on to that invoice fact. So press stop. That's not a lot of information, but you can imagine that you could really take that quite far. The recording could go on for a bit, and you could really give it some good, juicy information. So we've got our audio recordings. So the first thing we'll want to do with that is to upload it to a stage. And then when we do that, we then want to also transcribe it. So I've got one function that's going to do both of those things. I'll just expand this. It's just a bit of an explainer. What I'm doing is I'm taking the temporary path, so our previous function, just save that to little temp directory. I want to take it from that temp directory and I want to put it into our stage overwrite if it's already in there. I'll get the file name from that. And then what I will do is I'll use that file name to dynamically generate some SQL. So I'm doing select AITRANSCRIBE to file. So this is part of the new file data type that Snowflake has. So I'm showing it stage, showing it the name of the file. And then that will feed that into the AITRANSCRIBE function. Okay. So bringing that in, what I want to say is if our temp path exists, then I want to do that transcription. Okay. From there, what I want to do is actually to select the database, the schema, the tables. So what I'm going to do is just do some fairly simple functions here. Well, all we're doing is just doing a show databases, show schema in database, the one we've selected, and then show tables in schema with the database and the table that we have, database and schema we have selected, sorry. So in doing that, then what I want to do is to actually render this and make this look like something. So I've got fairly long function I'm going to put in here, but I'll quickly go over. Essentially, we've got a subheader. It says choose your tables. That's just give us some visual on the Streamlit, some user instruction. Then we're going to list the databases, have a little warning in case someone doesn't have access. And then I want my defaults to be the current DB. So I'm just doing, this is a Snowpark thing. My session dot get current database, my schema dot session dot get current schema. And then in Python doing something a bit fancy because I've got a list of databases. I feed it the current, ask what the index is, and then that will be my sort of default that I'm doing there. So I do the same for schema and I do the same for table. And then what I want to return here is the database, the schema, the tables, but also fully qualified, because downstream I'm going to want to do database name, schema name, dot table name. Okay. So if I bring that in here, so my selection will be the pick tables. So there we are. And then if I run that, it's going to give us a little bit more going on here. So this is our sandbox account. So this would be in the me database. And then because it's a demo, it's in there. But I will choose that signal. So I'm gonna, we have lots and lots going on here because we give everybody the ability to do what they want in our sandbox as one ought to. Okay, so pick my Semantic database, and I'll go to my March 25 case study, and that will load the tables that I can choose. And I want category, country, invoice, store, and vendor. I'll just let that load. Okay, there we are. It's fine. So I'll make a bit of space here. And then one thing I want to do is I'm going to bring in two functions for this. But now that we've selected these, what we want is actually to bring in the DDL. So I feed it my list. We'll see here. So what I'll do is if selection, doing some many ifs here. So if I've got my selection, then what I want to do is start querying the table DDL. And I'll get that fully qualified section. So I want, my table name dot schema name dot table name. As you can imagine, we are going to need to give the model some information. So that's what I'm doing here is I'm basically going in to get that DDL, show it what these tables actually look like, so it can then use that to do some, inference about how that semantic view could be designed.
Hey, Chris, very cool so far. I build these semantic views all the time when I'm doing, customer demos or working with customers. One of the interesting things we found is that in addition to kind of the table metadata and the get DDL information, is that other queries against the same tables actually have a wealth of information. Like if you think about, you talked about your colleagues who are maybe working in the same schema, maybe they're asking slightly different questions. And so what we've started to do is actually look at kind of query history and previous queries in the same domain and feeding that into kind of the semantic view creation process. So just a thought is, maybe in addition to that DDL, also including kind of past queries as information to help inform the semantic view creation.
Oh, that's a really interesting point. I'm so glad you said that, because as chance would have it,
How about that?
Yes, we did. I did think, oh, what if Josh raises this point? So yeah, very, very good idea. Obviously, the more kind of information you feed to a model, the better it is, unless you overload it. I should qualify that statement. But this is definitely, in terms of the trade-off between too much and too little, I think this is definitely a very, very good addition. So yeah, I'm going to add another function here, and that is going to accept as a parameter. It's going to take the list of these fully qualified tables. And what it will do is actually go into the Snowflake.account usage .access history table, expand those and go through those. And we don't need to go through this query. Basically, you just, it's all JSON. You need to do a bit of flattening. And then join that to our query history. So we can actually feed it a sample. We're going to do 10 rows. Feed it a sample of the kind of queries that are being run on top of your tables that you select. So that's what we do down here. We just filter to those, and I'm doing F string in Python, so you can get a list or feed in a list. So it's 10 rows. Maybe I do it as notch that up to 15. Live life on the wild side here, and then run that and give us the table names and the query text on top of those. So I'll also feed that in, do our sample results, our sample queries. There we are. So now we're building up a bit of a bit of context for the model, and that's going to give it a lot of insight and a bit of info to be creative with, I suppose. The last thing I want to actually feed into it before we get it to kick into action is I want to use another new bit of AI Snowflake functionality, the Cortex knowledge extensions. So if you're not familiar with the Cortex knowledge extension, what they are is they're basically a way of doing a Cortex search service, which is sort of shareable. So if you don't know what a Cortex search service is, that is basically a tool to help with retrieval augmented generation. You'll have a data set, and then you'll do a semantic search on top of that data set. Semantic search is really good because unlike a character similarity, with a semantic search, the closer two words are is determined by their meaning, not by their characters. So what I'm going to do is I'm going to use the Snowflake documentation Cortex knowledge extension. And what I'm doing here is I'm just going to actually hard code the query text because I just want to have semantic views in Snowflake. But I've got a Cortex search service I've built on top of this Cortex knowledge extension, called it the Docs Search Service. I feel like that's pretty standard. It's very easy to interact with. You just define your service, you search and give a query, the columns you want to be returned, and the limit of the rows. So now I've got 3 good pieces of context. What I got is first the DDL of the tables, then query history run on those tables, and then some documentation around semantic views. And all of that is going to go in to the prompt. So we better build that prompt. So I'll paste this in. This is another fairly big function. That's because it's got lots and lots of text. So what I'm doing here is I'm using ddent. I love using ddent when I'm Pythoning prompts because it just makes it human readable, which is really important. But I'm feeding in, all of this context, all of this information, principally the transcript, which is, the reason we're here, the big innovation. And then what I'm doing is I'm saying, okay, this is the task. This is what we want you to do. Here's some example DDL. Just took this from the docs, just so it's got a basic understanding. Then I've got inputs, so the user intent with the transcript, the tables that we want to build this on, some recently run queries, relevant documentation, and the DDL of the tables. And then I give it some requirements and say, these are the things you've got to do, and these are the things you've got to understand, which have been tailored to experience, essentially. Using it, realizing where it goes wrong, and trying to perfect it. And that is how we do things. So I will copy in the line that I forgot, which is the docs results from the previous bit. And then what I'm going to do is I'm going to call the this prompt building function. I'm going to put everything in there. On doing that, I then I'm in my final stage where I can actually just feed that prompt into Cortex Complete. So just put that there. I'm using the Snowflake ML libraries. So my results are just cortex.complete. Pick the model, put the prompt in, and just put that session in, and then return the string of the result. Okay. So I'll pop that down at the bottom. And then we have something. So what I'm going to do is just say if DDL SQL, see if there's something actually there. I'm then going to defend myself even more and just sort of say, if the little SQL wrapper isn't there, then put that in. Normally is, but just to be sure. Models like putting in code wrappers. But if that is there, then what I want to do is I want to put in my last function, which is just going to be a Streamlit display function, render semantic view. And I will put that down here. So let's run that. And here we go. So it is going to take a little bit of time because it does need to do some thinking. Brilliant. So you now have a semantic view. We have this DDL. It's actually produced quite a bit. And we have a little download button there as well. So let's put this to the test. Hopefully it will work and it'll say, yep, that's great. And there we go. Okay, so accounts payable analysis. So what I'll do is, I've already got the tab up here, but I'll close it just so you can see the process. I'm going to go to AI ML, and then I'm just going to go to Cortex Analyst, and I'll open that in a new tab because I'm a coward. You'll see accounts payable analysis is here. And I can do a little bit of a test. So let's look at counties, invoices, stores, vendors, see all that information here. Maybe I'll ask, which county do I do the most business in? And let's hope it understands. And there we go. And here we can see it is Polk. I don't know where Polk is, but there we are. We've been able to use our voice and use all different bits of context from query history to table DDL to build a semantic view. And I've achieved my mission of being as lazy as I can be. So I'm very, very proud of that.
That is awesome, Chris. I aspire to be as lazy as you.
Thank you very much.
That's fantastic. No, it feels like the kind of the inverse. When we invented our semantic views, the intent was, create the semantic view and talk to your data. And Chris has just shown how you can talk to your Snowflake and create a semantic view. So we've come full circle. Love the demo. I think this is really kind of a fantastic demonstration of not just the core semantic view capabilities, but the things that exist in Snowflake to allow you to do things like transcribe completely unstructured data, move that data around, use kind of the Cortex Complete functions to auto-generate code, and then building a working semantic view that answers a question. And now we know Polk is really killing it in terms of sales. So super exciting. One of the things I love about doing this kind of session is that This gives us ideas about what should we be building into the product. So what are the creative things our customers are doing? On the topic of semantic view creation, one of the things that we are rolling out at Build is this concept of a wizard that does semantic view creation. We're calling it Semantic View Autopilot. And over time, some of the things that maybe you saw in Chris's demo, for example, using things like query history to enrich semantic views, we'll start making it into our product as well. So really excited to see what Chris, you built today. Hope people found this super fascinating.